Good morning, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do another code review for you. And in this code review, what I'm going to be doing is I'm going to be going over clustering. And it's going to be Kmeans clustering to be precise. And what I'm doing is I created a program using Google Colab, which is a free online Jupyter notebook sponsored by Google. Google Colab is really good for writing programs in Python, but obviously it doesn't do everything, such as it does do animations. So if you wanted animations, you would have to use something like Replit. But most of what I do isn't animations and isn't tkinter, so I'm able to use Google Colab. After I created my program in Google Colab, what I wanted to do was I wanted to import the libraries. And when I imported the libraries, I'm going to import NumPy as NP, which is your numerical computation library, and it also creates NumPy arrays. And then I'm going to import Pandas as PD, which is your data processing library, and it also creates data frames. I'm going to import Seaborn as SNS, and that's a graphics library that also performs statistical functions on it, and it's built on top of Matplotlib. And so I'm going to import matplotlib.pyplot as PLT, which is your graphics library. And what it does is it takes the data points and plots them onto a graph. So we're also going to do something to fit up our figures. So plt.rcparams brackets figure.fig size equals bracket 16,9, and plt.style.use is brackets ggplot. So that's the style that they wanted to use. So after we've imported our data set and after we've imported our libraries and we have set up our parameters for our Matplotlib, we're going to read the data set. And so I decided to go ahead and use the Load Iris data set and sklearn's toy data sets because it's a very easy data set to use. And so from sklearn.datasets, import load iris. Iris equals load underscore iris brackets. Data equals iris.data. Target equals iris.target. And I was going to normalize the data, but when I normalized the data, it gave me a very low accuracy. So I decided in this instance not to normalize the data. But I'll go ahead and leave that in there, because what you're supposed to do is you're supposed to check your accuracy and then normalize your data and then check your accuracy. And the accuracy that is the best is going to be what you should use, either normalize it or not normalize it. So I normalized it. I had a very low accuracy, and then I didn't normalize it and I had a much better accuracy. And I think that because when you're using an estimator and you're making predictions using an estimator, they want the values to be really close together. But when you're clustering, I'm assuming that they don't want the values to be really close together, because if your values are really close together, then it's going to get confused. So I had a much higher level of accuracy without normalization than I did with normalization. And then I decided to create a data frame. Data equals pd.dataframe brackets data brackets data square brackets target square brackets equals target, and then data. So now we've got our data frame, and you can see we've got 4 columns and a target, and this is the iris data set. So these values that they're going to be giving you it's going to be like the length and the width of the flower. but I'd have to look it up, which I'm not going to in this video, to find out. One of them is a sepal and one of them is a petal, I believe, and you're looking at the length and the width of the sepal and the petal, and that's why you've got 4 columns of data giving you that information. And then the target is going to tell you what type of iris it is. So we check our size of the data frame. It's 150 rows by 5 columns. Sorry, that's the shape. We check the shape of the data frame. That's 150 rows by 5 columns. We check the size of the data frame. It's 750. So that's 150 times 5. So that tells you how many cells are in that data frame. We check the data columns. The data columns are 0, 1, 2, 3, and then target. And it's a D-type object. And now we check to see if we've got any null values, and we don't have any null values in that data set. Now we're going to analyze the target. So when we analyze the target, we use Seaborn to analyze the target, and 0, 1, 2. So 0, 1, and 2 are all the same values. They're all 50 each. Now we're going to do a heat map. So we've got a heat map of the data, and you can see how the different columns have a correlation to each other. Now we're going to take the data and we're going to convert it into a training and validation set. Okay, so train equals data dot sample brackets frac equals 0.9 comma random state equals 42 brackets. Now, so that's you're setting up your training set, and what the sample does is the sample randomizes it. The sample like shuffles the data set. It randomizes it, and the frac equals 0.9 means that the train is going to be 90% of the data. And then validation or DAHO equals data dot drop train index. So the validation is going to be what's remaining after you've dropped all the columns. Sorry, after you've dropped all the rows that are in the train index. And so now we set up our X train and our Y train. X train equals train dot IPOC square brackets colon comma colon -1 square brackets. And what that is X train is your train data set, everything except the last column. And Y train equals train dot IPOC square brackets colon comma -1 square brackets. So what that means is that your Y train is your last column of the data. And then we do the same thing with the val, X val and Y val. We use it exactly the same format. On X val, you get all the columns except the last column, and on Y val, you get the last column of data. So now what we're going to do is we're going to use Kmeans, and I spent pretty much last night and this morning working on different clustering methods, but Kmeans seems to be the best, and in addition to that, it gives the best accuracy as well. And so Kmeans is generally what everybody wants to use. And I tried a bunch of other algorithms, and they just didn't work well at all. I went on to Jason Brownlee's site, but I have a bit of difficulty with Jason Brownlee's site because he does a lot of odd things, and he doesn't do what's standard in data science. And since he doesn't do what's standard in data science, sometimes it's really difficult for me to try to figure out what he's doing. But I did look on his website, and I did try to use some of his work, and I just didn't find it helpful or beneficial. But we're going to go ahead and go through the Kmeans, and the Kmeans is going to be the only one that I'm going to go through, because all of the other clustering methods that I tried didn't really work, and it's no point in me going through it with you if it didn't really work. But if you go into sklearn, if it has a clustering, if you look under, do a search on cluster, you'll find all of the other clustering methods that they use. But since they didn't work on the iris dataset, that's not to say that they won't work on any dataset. But since they didn't work on the iris dataset, I decided not to use them. So with Kmeans, from sklearn.cluster import Kmeans. Kmeans equals Kmeans brackets in clusters equals 3 brackets dot fit brackets xtrain brackets. Kmeans dot cluster underscore centers underscore. So they give you the cluster centers for the 3 clusters that have been identified. Predictions equals Kmeans dot labels underscore. Predictions, you can see it's all either going to be 0, 1, or 2. We're going to look at the labels, then brackets Kmeans dot labels underscore is 135. Type brackets Kmeans dot labels underscore brackets equals numpy dot array. And then now what we're going to do is we're going to take the unique comma counts equals np unique Kmeans dot labels underscore comma return counts equals true, and we're going to put that in the dictionary, and we're going to zip it in the dictionary. So dict brackets zip bracket unique dot counts. So 0 is 48, 1 is 54, and 2 is 33. And so now we're going to check our accuracy, and this is a function that I put in there, and when we check our accuracy, we get 91% accuracy when we don't normalize the data. When we do normalize the data, we get much lower accuracy. So with the iris dataset, at least, you're not supposed to normalize the data. You get better accuracy if you don't normalize the data. So 91% accuracy isn't too bad. It's checking the difference between y-val and y-pred, or y-train and the predictions. So what we do is we plot a graph, plt.scatter brackets xtrain dot iloc square brackets colon comma 0 square brackets comma xtrain dot iloc square brackets colon comma 1 square brackets comma c equals predictions comma s equals 50 comma s math equals viridis, c math equals viridis. Centers equals Kmeans dot cluster underscore centers underscore plt dot scatter brackets center square brackets colon comma 0 square brackets comma centers square brackets colon comma 1 square brackets comma c equals black, s equals 200, alpha equals 0.5. And so what the first thing you're doing is you're plotting the data points onto a graph. That's what you're doing. You're plotting the data points onto a graph. And then the second thing you're doing is you're plotting the centers onto the same graph. So that was it for Kmeans clustering. We had other clustering techniques, but they didn't work, and I worked last night and this morning on them to try to get them to work, and I couldn't get them to work. So there's no point me reviewing the code if it's not very successful. But Kmeans clustering was very successful. Gave us 91% accuracy between y-train and predictions. So that's not too bad. So I'm going to go ahead and conclude this video because we've done our code review. We've talked about clustering, Kmeans, And thank you for all my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you for watching my video. And I look forward to making more videos for you in the future.